Hello there, and welcome to the Sleepy Facts channel. I'm so glad you found your way here. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to ocean mysteries rather than counting sheep. Either way, tonight's journey is for you. Let your mind relax, your breathing slow, and your body grow light as driftwood floating on gentle swells. Because tonight, we're exploring sea lions, those graceful mariners who dance between two worlds, equally at home on rocky shores, and in the endless blue, will drift from their playful nature to their remarkable adaptations, discovering how these animals navigate vast oceans and gather in colonies that echo with ancient songs. Some of what you hear tonight may surprise you, or at least spark curiosity as you drift off. Before we begin, if this helps you unwind, consider liking and subscribing, one sleepy soul at a time. Now, let's begin. Sea lions belong to a family called the eared seals, which means they possess external ear flaps that distinguish them from true seals. These small curved ears sit close to their heads, catching sounds both above and below the water's surface. The scientific name for their family is Otaridae, derived from the Greek word for little ear. Unlike their seal cousins who slide across ice on their bellies, sea lions walk on land using all four flippers, moving with surprising grace for animals so adapted to water. They rotate their rear flippers forward beneath their bodies, creating a gait that resembles a lumbering dance. This ability to walk rather than crawl gives them greater mobility on the rocky coastlines they call home, allowing them to climb steep cliffs and navigate tide pools with patient determination. There are 7 species of sea lions spread across the world's oceans, each adapted to their particular corner of the marine realm. The California sea lion barks along the Pacific coast of North America, while the Steller sea lion, largest of all, patrols the cold, northern waters. The South American sea lion calls the coasts of Peru, Chile, and Argentina home, and the Australian sea lion dwells in the waters down under. The Galapagos sea lion lives only on those volcanic islands. The New Zealand sea lion inhabits the subantarctic shores, and there once was a Japanese sea lion that has not been seen since the 1950s and is now considered extinct. Each species carries subtle differences in size, coloring, and behavior, yet all share that unmistakable sea lion essence: playful, intelligent, perfectly designed for a life split between land and sea. Sea lions are remarkably large animals, with males significantly bigger than females in most species. A male Steller sea lion can weigh over 2,000 pounds and stretch 11 feet from nose to tail, massive as a small car. Female Stellers are smaller but still impressive, weighing up to 800 pounds. California sea lions, the species most people recognize from aquariums and coastal piers, are more modest in size. Males reach about 800 pounds, while females weigh closer to 250. This size difference between males and females is called sexual dimorphism, and it plays an important role in sea lion society. The larger males compete for territory and mating rights, while the sleeker females focus their energy on feeding and raising pups. Despite their bulk, sea lions move through water like dancers, their size becoming weightless in the ocean's embrace. The sea lion's body is a masterpiece of streamlined design, built for speed and agility in the water. Their torpedo-shaped form tapers at both ends, reducing drag as they glide through currents. Thick layers of blubber insulate them from cold ocean temperatures, keeping their core warm even in frigid waters. Their skin is smooth and covered with short fur that lies flat when wet, creating an even sleeker surface. Unlike whales and dolphins who lost their hind limbs entirely, sea lions retained all 4, transforming them into powerful flippers. The front flippers are long and wing-like, propelling them forward with strokes that look like underwater flight. The rear flippers act as rudders, steering and providing extra thrust when needed. Every curve and contour of their bodies serves the singular purpose of moving efficiently through water, as if the ocean itself sculpted them over millions of years. Sea lions are social creatures who gather in large groups called colonies or rookeries, especially during breeding season. These gatherings can number in the thousands, transforming beaches and rocky outcrops into crowded neighborhoods filled with sound and motion. The air fills with barks, growls, and the calls of mothers searching for their pups among the masses. Bulls, the dominant males, stake out territories and defend them from rivals, though the conflicts rarely result in serious injury. Females move freely between territories, choosing their mates based on the quality of the territory rather than fighting ability alone. Young sea lions play in tide pools and chase each other across the rocks, learning skills they will need for their ocean lives. This communal living provides safety in numbers, as many eyes watch for danger and many voices raise the alarm. The colony pulses with life, yet within the chaos there exists an order, an ancient social structure that has served sea lions for countless generations. The sea lion's eyes are large and dark, adapted to see in the dim light of deep water. Unlike human eyes that work best in air, sea lion eyes function equally well above and below the surface. Their corneas are flattened and their lenses are spherical, corrections that compensate for the way water bends light differently than air. This allows them to hunt effectively at depths where sunlight barely penetrates, tracking the silver flash of fish in the twilight world beneath the waves. On land, their vision is slightly nearsighted, but still sharp enough to recognize their pups among hundreds and spot approaching predators. They possess a reflective layer behind the retina, called the tapetum lucidum, which bounces light back through the retina a second time, enhancing their vision in darkness. This is why their eyes sometimes seem to glow when caught by flashlight or camera, a brief shimmer like distant stars. They see the world in fewer colors than humans do, but they perceive movement and contrast with exceptional clarity, which matters more in the ever-shifting seascape. Sea lions hear remarkably well both in air and underwater, a dual ability that few animals possess. Their external ear flaps can close when diving, preventing water from entering the ear canal, while still allowing sound to reach the inner ear through bone conduction. In water, sound travels nearly 5 times faster than in air, and sea lions have adapted their hearing to process these rapid vibrations. They can detect frequencies ranging from 75 Hz up to 75,000 Hz, giving them a hearing range that extends well beyond human capability in both directions. This means they hear the low rumbles of distant ships and the high-pitched clicks of hunting dolphins with equal ease. Mothers and pups use specific calls to find each other in crowded colonies, each voice unique enough to be recognized among thousands. The ocean is not the silent world we sometimes imagine. It is filled with sounds, and sea lions navigate this acoustic landscape as naturally as they navigate currents and tides. The whiskers of a sea lion, called vibrissae, are sophisticated sensory organs that detect the slightest movements in the water. Each whisker is embedded in tissue rich with nerve endings, and together they form a detection system so sensitive that a blindfolded sea lion can follow the path a fish took through water 30 seconds after it passed. The whiskers pick up the subtle turbulence that swimming creates, translating it into a map of movement the sea lion can read and understand. Scientists have tested this ability by having sea lions track the underwater trail of a miniature submarine, and the sea lions succeeded time after time, following wakes that were invisible to the human eye. In murky water where vision fails, these whiskers become the primary sense, allowing sea lions to hunt in darkness or through clouds of stirred-up sediment. They extend forward when the sea lion is curious or hunting, then relax back against the face during rest. Like fingers reading braille, they translate the ocean's movements into meaning. Sea lions are carnivores who feed primarily on fish and squid, though their diet varies by species and location. California sea lions favor anchovies, sardines, and rockfish, diving repeatedly through the day to catch small schooling fish. Stellar sea lions hunt larger prey, including salmon, Pacific cod, and even small sharks. Some sea lions have learned to follow fishing boats, snatching fish from nets or waiting for discarded bycatch. an opportunistic behavior that sometimes brings them into conflict with fishermen. They do not chew their food but swallow it whole or tear it into manageable pieces, their sharp teeth designed for gripping rather than grinding. A large male sea lion may consume 40 pounds of fish in a single day, though they can also fast for extended periods when food is scarce, or during breeding season when males are defending territories. They are patient hunters, using speed and agility rather than ambush, pursuing their prey through the water with grace that makes the chase look effortless, like a game played for pure joy. When diving, sea lions demonstrate physiological adaptations that allow them to stay underwater for extended periods. Most dives last between 3 and 10 minutes, though they are capable of remaining submerged for much longer when necessary. The deepest recorded dive by a California sea lion reached 900 feet, while stellar sea lions have been documented diving below 1,500 feet into the crushing darkness of the deep sea. Before diving, they exhale most of the air from their lungs, collapsing them to prevent nitrogen from dissolving into their bloodstream, which would cause decompression sickness. Their heart rate slows dramatically, sometimes dropping to just 10 beats per minute, conserving oxygen for vital organs. Blood flow redirects away from the skin and digestive system, concentrating in the brain, heart, and muscles. Their muscles contain high levels of myoglobin, a protein that stores oxygen, giving the muscles a dark red color and allowing them to work without fresh oxygen for minutes at a time. When they finally surface, they breathe rapidly to replenish their oxygen stores, then dive again, descending into the blue with barely a splash. The sea lion's front flippers are engineering marvels, transformed forelimbs that retain the bone structure of a mammalian arm. Inside each flipper lie the same bones found in a human arm and hand: the humerus, radius, ulna, carpals, metacarpals, and phalanges, but elongated and flattened. The fingers are encased in a mitt of skin and connective tissue, creating a single wing-like surface. These flippers provide thrust through a motion similar to a bird's wings, sweeping down and back in powerful strokes that can propel a sea lion through water at speeds exceeding 25 miles per hour. The shoulder joint is incredibly flexible, rotating through a full 360 degrees, which allows for tight turns and sudden direction changes that would make a fighter pilot jealous. When swimming slowly or maneuvering in tight spaces, they use their flippers like oars, sculling through the water with precise control. On land, these same appendages support the sea lion's weight, bending at the wrist to create a walking stance. The transition from water to land and back again happens seamlessly, the flippers serving each environment equally well. Sea lion pups are born on land, usually on rocky beaches or protected coves, where waves provide a rhythmic soundtrack to their first hours. The mother gives birth to a single pup after a gestation period of nearly a year, and the pup enters the world with eyes open and covered in a dark coat of fur. Within minutes, the newborn begins vocalizing, establishing the unique call that will allow its mother to identify it among hundreds of other pups. The mother memorizes her pup's scent and sound during the first hours, creating a bond that will last through months of separation and reunion. The pup weighs around 15 to 20 pounds at birth and measures about 30 inches long. For the first week, the mother stays constantly with her pup, nursing it with milk that contains 25% fat, far richer than cow's milk or even human milk. This high-fat milk allows the pup to grow rapidly, building the blubber layer it will need for warmth and energy. The pup's dark natal coat will later molt and be replaced with the lighter adult coloring. But in these early days, it makes the youngster easy to spot against pale rocks and sand. Mother sea lions must balance the demands of nursing with the need to feed themselves, a challenge that defines their early relationship with their pups. After that first week of constant attendance, the mother leaves her pup on the beach and returns to the ocean to hunt. She may be gone for 2 to 3 days, diving repeatedly to catch enough fish to replenish her energy and produce milk. During her absence, the pup waits on shore with other pups, sometimes forming small groups called pods. When the mother returns, she calls out and the pup answers, and they find each other through this vocal exchange, even in a colony of thousands. The reunion is touching. They touch noses, smell each other, reaffirming their bond before the pup begins nursing again. This cycle of departure and return continues for months, gradually spacing out as the pup grows and begins to explore the tide pools on its own. The mother may travel 50 miles or more from the colony during her hunting trips, but she always finds her way back, guided by memory and instinct to the spot where her pup waits. Sea lion pups learn to swim gradually, gaining confidence through play and exploration. At first, they are hesitant to enter the water, staying in shallow tide pools where they can touch bottom. They splash and blow bubbles, getting used to the feeling of water against their faces. Older pups serve as role models, demonstrating that the ocean is nothing to fear. Around 2 weeks of age, most pups take their first real swim, paddling in circles and staying close to shore. Their mothers do not teach them to swim. The ability is instinctive, but they do supervise, watching from nearby rocks or swimming alongside to encourage them. Over weeks, the pups venture farther, diving deeper, holding their breath longer. They chase each other through kelp forests and learn to catch small fish. Some pups take to water immediately, while others need more time, but eventually all overcome their initial caution. By 3 months old, most pups are competent swimmers, though still clumsy compared to the adults. They are beginning to understand the element that will define their lives, learning its moods and rhythms like a language spoken without words. The vocalizations of sea lions create a constant soundtrack in their colonies, a complex symphony of barks, roars, and bellows. Each individual has a distinct voice, and sea lions can recognize each other by sound alone. Males produce loud roars to advertise their territories and warn away rivals, sounds that can carry for hundreds of yards across water and rock. Females bark to call their pups and to communicate with other females in the colony. Pups bleat and cry, especially when hungry or separated from their mothers. These are not random noises but purposeful communications, conveying specific information about identity, location, and emotional state. Scientists have identified different call types associated with different behaviors. One bark means aggression, another signals alarm, a third expresses contentment. The overall effect is chaotic to human ears, but within the noise there is meaning. At night, the colony quiets but never falls completely silent. There are always voices calling across the darkness, mothers and pups checking in with each other, maintaining their bonds even in sleep. Sea lions spend much of their time hauled out on land, resting and digesting their meals. They gather in groups, often piling on top of each other despite having plenty of space. Seeking warmth and companionship, they drape themselves over rocks with complete abandon, looking utterly relaxed, as if the stone beneath them were the most comfortable bed imaginable. Their breathing slows, and they may sleep for hours, occasionally shifting position or scratching an itch with a flipper. During hot weather, they regulate their temperature by holding their flippers in the air, allowing wind to cool the blood vessels close to the surface. They also move into the water to cool down, then return to shore once their body temperature drops. In cold weather, they huddle together, conserving warmth through shared body heat. These hauling out sites are carefully chosen, usually offering easy access to water, protection from land predators, and good visibility to spot danger. Some sites have been used by sea lions for hundreds of years, the rocks worn smooth by countless bodies over countless generations. The blubber layer beneath a sea lion's skin serves multiple purposes beyond simple insulation. It stores energy that can be metabolized during times of fasting, such as when males are defending territories and cannot leave to hunt. It provides buoyancy, helping sea lions float effortlessly at the surface when they need to rest. It cushions internal organs from the pressure changes of deep diving and from impacts against rocks in rough surf. The thickness of the blubber varies by season, building up when food is abundant and thinning during times of scarcity or high energy expenditure. In the coldest waters, Sea lions maintain a blubber layer, several inches thick, a warm coat worn beneath the skin. The blubber also changes the sea lion's shape, creating those smooth curves and the substantial presence that makes them seem so solid and grounded, even as they embody fluidity. It is stored life, held in reserve against future need. Another adaptation that allows these animals to thrive in an environment where food supplies fluctuate with seasons and ocean currents. Sea lions can hold their breath for impressive durations, though exactly how long varies with the individual and the circumstances. The average dive lasts just a few minutes, which is sufficient for most hunting. When necessary, however, they can extend this time considerably. Young sea lions in training have held their breath for 10 minutes or more in controlled settings. The longest recorded dive duration is over 20 minutes for certain species. This ability comes from the same suite of adaptations that allows deep diving, the slowed heart rate, the oxygen-storing myoglobin in muscles, the redirection of blood flow. The sea lion appears to know its limits, surfacing before oxygen debt becomes critical. After particularly long or deep dives, they spend more time at the surface breathing rapidly, repaying the oxygen debt accumulated below. They seem to balance risk and reward instinctively, pushing their limits when the hunting is good, but never quite to the point of danger. This invisible calculation happens with each dive, a decision made in the moment the sea lion slips beneath the surface and begins its descent into the blue twilight. The skin of a sea lion is tougher than it appears, especially on males who bear the scars of countless territorial disputes. The neck and shoulders of adult males are often covered in thick, calloused skin that can be 2 inches deep in places, armor that protects them during the ritual combat of breeding season. Females have smoother, thinner skin, without this protective layer since they do not engage in the same aggressive behavior. The skin color varies by species, from the golden brown of California sea lions, to the pale tan of Australian sea lions, to the rich chocolate of South American sea lions. All sea lions molt annually, shedding their fur gradually over several weeks. During molt, they may appear patchy and shabby, but this is a natural process that replaces worn fur with fresh growth. The new fur comes in sleek and glossy, evidence of health and good nutrition. Sea lion skin heals remarkably quickly from minor wounds and abrasions, which is fortunate given the rough terrain of their coastal homes where sharp rocks and barnacles are everywhere. Sea lions are endothermic, meaning they maintain a constant internal body temperature regardless of their surroundings. This warm-bloodedness requires tremendous energy compared to cold-blooded animals like fish, which is why sea lions must eat so much. Their core temperature stays around 100 degrees Fahrenheit, similar to humans. In cold water, heat leaches away rapidly. Water conducts heat 25 times faster than air, so sea lions must constantly generate warmth through metabolism and protect it through blubber insulation. In warm weather or after exertion, they face the opposite problem of overheating. They cannot sweat like humans, so they use behavioral strategies to cool down, entering the water, holding flippers up to catch the breeze, panting to release heat through respiration. They seek shade when available or wet their bodies by splashing. This constant regulation of body temperature happens automatically, the nervous system making adjustments moment by moment, maintaining the narrow range of temperatures within which mammalian bodies function properly. The bones of sea lions are dense and heavy, unlike those of birds which are hollow to reduce weight for flight. This density helps sea lions dive by making them less buoyant, reducing the energy needed to swim down against the water's natural tendency to push them upward. The ribs are thick and strong, protecting the lungs and heart from the pressure of deep water. The skull is robust with pronounced brow ridges and sagittal crests, where powerful jaw muscles attach. The spine is flexible, allowing the sea lion to arch and twist its body for quick turns and complex maneuvers. All of these bones are alive, constantly being broken down and rebuilt through the process of bone remodeling, adapting to the stresses placed on them. Young sea lions have bones with growth plates that allow them to lengthen, and these plates gradually close as the animal reaches adult size. The skeleton is a framework, but also a dynamic structure that changes throughout life, recording in its density and shape the history of how that individual sea lion lived and moved through its world. Sea lions possess remarkable spatial memory, allowing them to navigate vast stretches of ocean and return to specific locations with precision. They remember the locations of productive hunting grounds and visit them repeatedly, sometimes traveling 100 miles or more from their colony. They recognize underwater landmarks, rock formations, kelp beds, drop-offs into deeper water, and use these features to orient themselves. They may also use the sun's position, the Earth's magnetic field, and the sound of waves breaking on distant shores as navigational cues. Mothers remember exactly where they left their pups on crowded beaches and swim directly to that spot, even after days away. This mental mapping of space must be three-dimensional, encompassing not just horizontal distance, but depth as well. A complete model of their territory held in memory. They share this information with their young through example, leading them on trips and establishing the traditional routes and gathering places that define their population. These mental maps are passed down through generations, a cultural knowledge as important as any genetic inheritance. The heart of a sea lion beats strongly in its chest, a four-chambered organ similar in structure to a human heart, but adapted for a very different lifestyle. At the surface, the heart rate matches the sea lion's activity level, faster during swimming, slower during rest. A resting sea lion might have a heart rate of 80 beats per minute, comparable to a resting human. But when diving, the heart rate drops dramatically through a process called bradycardia. The heart slows to just 10 or 15 beats per minute, sometimes even slower. This profound slowing conserves oxygen, allowing the blood's oxygen supply to last much longer. The heart continues to beat steadily at this reduced rate, circulating blood to the brain and vital organs while peripheral blood vessels constrict. When the sea lion surfaces, the heart accelerates again, almost immediately, returning to normal within a few breaths. This ability to modulate heart rate so dramatically, so quickly, is part of what biologists call the mammalian dive reflex. And it exists in humans too, though far less developed than in sea lions who refined it over millions of years of evolution in the sea. The teeth of a sea lion are designed for grasping rather than chewing, pointed and sharp like a dog's teeth. They have 4 large canine teeth at the front, 2 upper and 2 lower, which they use to grasp slippery prey. Behind the canines are smaller premolars and molars with pointed cusps that help hold on to struggling fish. The teeth are all the same basic shape, a condition called homodonty. Unlike humans who have different tooth types for different functions, sea lions have between 34 and 38 teeth, depending on species, and these teeth must last their entire lives. There is no second set like the one that replaces human baby teeth. The teeth wear down over time, becoming smooth and blunted, especially in older animals. Scientists can estimate a sea lion's age by examining tooth wear and by counting growth layers in teeth, similar to counting tree rings. The teeth are cream-colored when clean but often appear darker due to staining from fish oils and algae. Despite constant use, sea lion teeth rarely develop cavities, perhaps because their diet lacks the sugars and starches that feed cavity-causing bacteria in human mouths. Sea lions are surprisingly agile on land, despite being fundamentally aquatic animals. They can move faster than a human can walk, reaching speeds of 5 or 6 miles per hour in short bursts when alarmed. They bounce along using their front flippers to propel themselves forward, while their rear flippers swing underneath and provide additional thrust. Going uphill or over obstacles, they use a motion that looks like a combination of hopping and climbing, pulling themselves up with their front flippers and pushing with their rear ones. They can climb surprisingly steep slopes, ascending rocky cliffs to reach hauling out spots high above the surf. Going downhill is more challenging, and they often slide or tumble, though they seem unconcerned by these ungainly descents. On smooth sand, they leave distinctive tracks, the drag marks of their bodies between flipper prints. These tracks tell stories to those who can read them. Which direction the sea lion went, whether it was moving quickly or slowly when it stopped to rest. The tracks are temporary marks in sand, erased by wind and tide, but constantly renewed as sea lions come and go between land and sea. The lungs of sea lions are proportionally larger than human lungs relative to body size, allowing them to take in more oxygen with each breath. The lungs are divided into lobes and contain millions of tiny air sacs called alveoli, where oxygen transfers into the bloodstream. Before diving, sea lions exhale rather than inhale, collapsing their lungs to prevent gases from being absorbed under pressure. This seems counterintuitive. Why empty your lungs before holding your breath? But it prevents nitrogen narcosis and decompression sickness that would result from breathing compressed air at depth. The collapsed lungs also mean less buoyancy, making diving easier. The oxygen the sea lion needs for its dive is already stored in its blood and muscles, not in its lungs. The lungs remain collapsed during most of the dive, then re-inflate when the animal surfaces. The thick muscles surrounding the ribcage control this expansion and compression with precision. Each breath at the surface is purposeful, several quick inhalations that replenish oxygen stores before the next dive. Sea lions can see well enough underwater to hunt by sight, but their whiskers provide an advantage in turbid water or darkness, where vision fails. The whiskers on a sea lion's face are not just hair. Each one is a highly specialized sensory organ. They grow from follicles packed with nerve endings that detect even tiny movements or pressure changes. When a fish swims past, it creates a disturbance in the water, a trail of tiny whirlpools and pressure gradients that persist for seconds after the fish has moved on. The sea lion's whiskers detect this trail and can even determine which direction the fish went and how fast it was swimming. In experiments, scientists have blindfolded sea lions and found they can still track and capture prey using whiskers alone. Some sea lions have lost their eyesight due to injury or disease, but continue to hunt successfully, relying entirely on whiskers and hearing. The whiskers extend forward when hunting, making the sea lion's face appear broader and more alert. Each whisker can move independently, controlled by tiny muscles in the face, allowing the sea lion to aim them towards sounds or movements of interest. Sea lion milk is extraordinarily rich, containing enough fat and protein to fuel rapid pup growth. The milk is about 25% fat, compared to just 4% in cow's milk and 3% in human milk. This concentrated nutrition means pups gain weight quickly during the nursing period, building the blubber layer they need for warmth and energy reserves. The milk also contains antibodies that protect the pup from diseases in its environment. Pups nurse for several months, though the duration varies by species. California sea lion pups typically wean at 6 to 12 months, while Galapagos sea lion pups may nurse for up to 3 years. During nursing, the pup's growth is visible week by week, its body filling out and becoming more seal-shaped. The mother's body bears the cost of this milk production. She loses weight during the nursing period and must hunt intensively to sustain both herself and her pup. The bond between mother and pup, reinforced through nursing, is one of the strongest in nature. Even after weaning, young sea lions may stay near their mothers for months or years, learning through observation the skills they will need to survive. The lifespan of a sea lion varies by species and environmental conditions, but most live 15 to 25 years in the wild. California sea lions average about 17 years for males and 25 for females. The difference likely due to the stresses males face during breeding season. Stellar sea lions can live into their early 20s. In captivity, where food is guaranteed and medical care available, sea lions sometimes reach 30 years or more. The oldest known sea lion lived to 35 years in a managed care facility. Age brings visible changes. Older sea lions have worn teeth, scarred skin, and sometimes cataracts that cloud their eyes. They move more slowly on land and may take longer to recover from dives. Despite these signs of aging, many older sea lions remain active and continue to breed, especially females who do not face the same intensive competition as males. They carry knowledge accumulated over decades, where to find food during different seasons, how to avoid dangers, when to migrate, and where to go. The oldest females often hold positions of respect in the colony, their experience benefiting the younger generations who watch and learn from these survivors, who have seen countless seasons come and go. Sea lions face predators both in the water and on land, though the threats vary by location and species. In the ocean, the primary danger comes from large sharks, particularly great white sharks and tiger sharks who patrol the waters where sea lions hunt and travel. Orcas, or killer whales, also hunt sea lions in some regions, using sophisticated cooperative strategies to capture their prey. The attacks usually happen quickly, a sudden rush from below or from the murky depths where visibility fails. Young sea lions and those distracted by hunting are most vulnerable. On land, the dangers are different but no less real. In some areas, coyotes and bears patrol the beaches looking for unattended pups, and large birds of prey occasionally take very young animals. Sea lions have evolved wariness as a response. They enter the water cautiously, scanning the surface, and they position themselves on rocks where they can see approaching threats. They gather in groups because many pairs of eyes spot danger sooner than one pair alone. When a threat appears, the alarm spreads quickly through vocalizations and body language, and the entire colony may flee into the water or scramble to higher ground depending on where the danger originates. The social structure of sea lion colonies during breeding season is complex and based on competition among males. The largest, strongest males establish territories on prime beach real estate, where females prefer to haul out. These bulls defend their territories vigorously, facing down rivals with displays of aggression, loud vocalizations, chest bumping, and sometimes actual fights involving biting and shoving. Most disputes resolve through display rather than combat, but injuries do occur. The victorious males may hold territories for several weeks, during which time they barely eat or sleep, constant vigilance required to maintain their position. Females move through these territories freely, choosing where to give birth and which males to mate with. Their choice is based less on the male himself than on the quality of his territory, proximity to water, protection from surf, space for the pup to be born. Males who cannot establish territories wait at the periphery, and if a territory holder shows weakness from exhaustion or injury, a younger male may challenge him and take over. This hierarchy creates order from what could be chaos, ensuring that the strongest genetics pass to the next generation while maintaining social cohesion. Sea lions communicate through a combination of vocalizations, body language, and physical touch. Aggressive communication involves direct stares, open mouths, displaying teeth, and charging movements that may or may not result in actual contact. Submissive sea lions avoid eye contact, turn their heads away, and retreat from the aggressor. Playful behavior between sea lions involves chasing, gentle biting, and swimming in synchronized patterns. Mothers and pups communicate constantly through a call and response pattern, the mother calling out and waiting for her specific pup to answer before moving toward the sound. Physical touch is important too. Sea lions nuzzle each other, rest with bodies touching, and pups seek physical contact with their mothers whenever possible. These tactile communications reinforce bonds and provide comfort. The meaning of any given behavior depends on context. A movement that signals play in one situation might signal aggression in another. Sea lions read these nuances fluently, navigating their social world with sensitivity to subtle cues that humans are only beginning to understand. The digestive system of a sea lion is adapted to process large quantities of fish efficiently. The stomach is simple and sac-like, capable of holding several pounds of fish at once. Strong acids and enzymes break down the flesh rapidly, extracting nutrients. The intestines are relatively short compared to herbivores, reflecting the easily digestible nature of their diet. Food passes through the system in 4 to 6 hours, much faster than in humans where digestion takes more than 24 hours. This rapid processing allows sea lions to eat again soon after their last meal, important for animals that must consume large amounts of food to fuel their high metabolisms. They occasionally swallow stones, called gastroliths, which may help grind food in the stomach or serve as ballast for diving, though scientists are not entirely certain of their purpose. Sea lions can go without food for extended periods when necessary, living off their blubber reserves. Males during breeding season may fast for up to 2 months while defending territories, losing a quarter of their body weight. Their bodies shift metabolism during fasting, becoming more efficient at extracting energy from stored fat, while protecting muscle tissue from breakdown. The intelligence of sea lions is considerable, evidenced by their problem-solving abilities and capacity to learn. In research settings, sea lions have demonstrated understanding of concepts like greater than and less than, same and different, and if-then logical relationships. They can follow pointing gestures from humans, a skill that even chimpanzees struggle with. They can learn complex sequences of behaviors and remember them for years. Their working memory is excellent. They can keep track of multiple objects and their locations, updating this mental map as things move. Sea lions in oceanariums learn elaborate performances, though these trained behaviors represent only a small fraction of their natural intelligence. In the wild, their intelligence shows in hunting strategies that adapt to changing conditions, in the navigation of complex social relationships, and in their ability to learn from each other. Young sea lions watch adults and imitate their behaviors, a form of cultural transmission. An older sea lion who discovers a new fishing technique may pass it to others who observe and copy, spreading innovation through the population without any genetic change. The migration patterns of sea lions vary by species and population, with some groups traveling thousands of miles annually, while others remain relatively sedentary. Young California sea lions, particularly males, often migrate north after weaning, traveling up the Pacific coast to British Columbia and beyond in search of food. They may spend months or even years in these distant waters before returning to their natal colonies to breed. Adult females tend to stay closer to breeding colonies year-round, making shorter trips to hunt but always returning to familiar shores. Stellar sea lions in Alaska undertake seasonal movements, following fish populations as they shift with water temperatures and currents. These migrations are not random wandering but purposeful travel to known destinations, routes learned from other sea lions or discovered through exploration and remembered for future use. Some sea lions have been tracked traveling 100 miles offshore into the open ocean, diving deep into waters where the sea floor lies far below. These pelagic journeys take them away from familiar landmarks into the featureless blue. Yet they navigate successfully and return to pinpoint locations on the coast. The mechanisms of this navigation remain partially mysterious, likely involving multiple senses and strategies working together. Sea lions have been observed using tools in rare instances, a behavior that speaks to their cognitive flexibility. Individual sea lions have been seen using rocks to open shellfish, holding the rock in their front flippers and striking down on the shell until it cracks. This behavior is not common and appears to be learned rather than instinctive, passed from one individual to another through observation. In aquariums, sea lions sometimes use objects as toys, carrying things in their mouths, tossing them, retrieving them, inventing games that suggest an understanding of object permanence and cause and effect. They have been observed using kelp fronds as tools to scratch itches on parts of their body they cannot reach with their flippers. These instances of tool use are simple compared to the sophisticated tool use of primates or crows, but they demonstrate that sea lions can conceive of objects as having utility beyond their immediate form. They can imagine a rock as a hammer, a kelp frond as an extension of their flipper. This cognitive leap, this ability to see potential uses rather than just immediate reality, is a hallmark of intelligence shared by relatively few species. The molt of a sea lion happens annually, usually in summer or early fall after breeding season concludes. The old fur loosens and falls out gradually, replaced by new growth underneath. Unlike some seals that molt dramatically, shedding large patches of skin and fur together, sea lions molt more subtly, the change happening over several weeks. During this time, they may appear ragged and discolored, the old fur faded and patchy. They spend more time on land during molt, as the process is energy intensive, and they seem less efficient at maintaining body temperature while molting. They are more irritable during this period too, perhaps uncomfortable as the old fur loosens. The new fur that emerges is sleek and darker than the old, and the sea lion looks renewed, younger, somehow. The molt is triggered by hormonal changes, influenced by day length and temperature, an annual cycle timed to allow the animal to have its best insulation before winter arrives. Molting is necessary because fur wears out. It fades in the sun, breaks down from saltwater exposure, and harbors algae and parasites. The fresh coat that follows is clean and efficient, ready for another year of use. Sea lions are capable of sleeping with one half of their brain at a time, a phenomenon called unihemispheric slow-wave sleep. This allows them to rest while maintaining some awareness of their surroundings, useful for animals that face predation threats and need to surface regularly to breathe. When sleeping in water, sea lions often float vertically with their nostrils just above the surface, bobbing gently with the waves. They may also sleep on land, sprawled on rocks in positions that look uncomfortable, but apparently suit them perfectly. During unihemispheric sleep, one half of the brain shows the slow waves characteristic of deep sleep, while the other half maintains a more alert pattern. The sleeping hemisphere controls the opposite side of the body, so one eye may be closed while the other remains slightly open, watching. After a period of time, the two hemispheres switch, giving each side a turn at deep rest. This sleep pattern is common among marine mammals and some birds, an elegant solution to the problem of resting in an environment where you cannot fully let down your guard. Even while sleeping, sea lions remain partially present, never completely vulnerable. The population sizes of sea lion species vary dramatically, reflecting different conservation challenges and historical impacts. California sea lions are relatively abundant, numbering around 250,000 individuals, and their populations have been increasing since the passage of the Marine Mammal Protection Act in the United States in the early 1970s. Stellar sea lions, however, are divided into two populations, an eastern population that is stable and a western population that declined dramatically in the late 20th century and remains endangered today. The causes of this decline are complex and likely involve multiple factors, including reduced prey availability due to overfishing, predation, and environmental changes. The Australian sea lion is one of the rarest, numbering only around 12,000 individuals, and its populations are slowly declining. The New Zealand sea lion is also considered endangered, with numbers hovering around 10,000. The Galapagos sea lion, endemic to those islands, numbers around 20,000 and faces threats from disease, El Niño events that disrupt food supplies, and interactions with fisheries. The Japanese sea lion is extinct, last seen alive in the 1950s, a casualty of overhunting and habitat loss. These varying fortunes remind us that even successful species remain vulnerable to human impacts and environmental changes that cascade through ocean ecosystems in ways we are still learning to understand. Sea lions maintain a delicate balance of salt and water in their bodies, despite living in a saltwater environment and consuming salty prey. Their kidneys are specially adapted to concentrate urine, eliminating excess salt while conserving fresh water. They obtain most of their fresh water from their food. Fish contain water that is less salty than seawater, and from metabolic water produced when their bodies break down fat for energy. They do not drink seawater directly, as this would require more energy to eliminate the salt than they would gain from the water. In some circumstances, such as when stranded in areas without access to the ocean, sea lions can become dehydrated despite being aquatic animals. Their kidneys work constantly to maintain the precise concentration of salts and minerals needed for cells to function, expelling excess through urine and to a small degree through feces. This osmoregulation happens automatically, adjusted moment by moment as conditions change. It is one of many invisible physiological processes that allow sea lions to thrive in an environment that would quickly kill a human through dehydration and salt poisoning. The fur of a sea lion is not waterproof like that of sea otters, who rely on trapped air for insulation. Instead, sea lion fur gets thoroughly wet and serves primarily to protect the skin from abrasion rather than to insulate. The real insulation comes from the blubber layer underneath the skin. This means sea lions can survive with relatively sparse fur, compared to otters who would freeze without their dense coats. Sea lion fur is short and coarse, lying flat against the body when wet to reduce drag. Each hair is solid, not hollow, and does not trap air. The fur color varies by species and by individual, ranging from dark brown to tan to almost golden. Males often have darker manes around their necks and shoulders, giving them a more impressive appearance during breeding displays. Pups are born with dark fur that molts to adult coloring within their first year. The fur requires no grooming or maintenance beyond the occasional scratch with a flipper. It serves its purposes quietly, protecting skin, providing slight camouflage when swimming, perhaps playing a role in tactile sensation. But unlike pinnipeds like walruses who have almost no fur, sea lions retain this covering, a reminder of their terrestrial ancestry and the time, millions of years ago, when their ancestors walked on land with full coats of mammalian hair. The play behavior of sea lions, particularly in young animals, serves important developmental functions. Pups chase each other across rocks and through tide pools, practicing the swimming and diving skills they will need for hunting. They play fight, grappling with each other in ways that look serious but involve no real aggression or injury. Learning the social skills needed to navigate colony dynamics as adults. They investigate objects, picking up kelp or shells and tossing them, developing coordination and understanding of their environment. Adult sea lions play too, though less frequently, sometimes chasing fish without eating them, jumping completely clear of the water in behaviors called breaching, or surfing in waves near shore. This playfulness in adults may serve to maintain physical conditioning, strengthen social bonds, or simply provide enjoyment. The capacity for play in animals is often linked to intelligence. Play requires imagination, the ability to understand that certain actions are not real threats or real hunting, but symbolic versions of those activities. Sea lions at play are clearly enjoying themselves, and this suggests an inner life richer than mere stimulus and response. They are not just surviving but experiencing their world, finding joy in movement and companionship, and the simple pleasure of being alive. The reproductive cycle of sea lions involves delayed implantation, a fascinating adaptation that helps synchronize births to the optimal season. After mating, the fertilized egg develops to the blastocyst stage, then stops, floating free in the uterus without implanting in the uterine wall. This embryonic diapause lasts for about 3 months, during which development is paused. Then, triggered by environmental cues and hormonal changes, the blastocyst implants and development resumes. This delay means that even though the total time from conception to birth is nearly a year, active gestation is only 8 to 9 months. The advantage of this system is that it allows females to mate during the breeding season when all the adults are gathered together, but delays the energetically demanding pregnancy until after the female has had time to recover from nursing the previous pup and build up her fat reserves. The timing works out so that pups are born during the same season each year, when weather is favorable and food is most abundant. This elegant biological mechanism separates the act of mating from the beginning of pregnancy, giving the mother's body time to prepare for the tremendous investment that pregnancy and nursing represent. The eyesight of sea lions extends into the blue-green part of the spectrum, where light penetrates deepest into ocean water. Red light is absorbed quickly, so red appears dark or black at depth. but blues and greens remain visible even hundreds of feet down. Sea lion eyes are adapted to see these wavelengths most clearly, which makes sense for animals hunting in an environment where these are the only colors available. This is why many deep-sea fish appear red. In their environment, red equals invisible. Sea lions, hunting squid or fish in the twilight zone of the ocean, rely on detecting subtle contrasts in these blue-green hues, spotting the silhouette of prey against the slightly brighter water above or the slightly darker water below. Their eyes adjust quickly to changing light levels as they dive, the pupils dilating in darkness and constricting in brightness. The lens of the eye is harder and more spherical than a human lens, corrections necessary to focus light properly in the dense medium of water. These adaptations make sea lion eyes excellent underwater instruments, though they sacrifice some detail vision in air, a trade-off that makes sense for animals that do their seeing primarily beneath the surface. Sea lions have been known to interact with other species in surprisingly complex ways. They sometimes associate with dolphins while hunting, the two species apparently benefiting from each other's presence by herding fish into tighter schools that are easier to catch. Sea lions have been observed playing with other marine animals, including turtles and even small sharks, behavior that seems to have no survival purpose but simply expresses curiosity or playfulness. In some areas, sea lions and seals haul out together on the same beaches, coexisting peacefully despite being different species with different evolutionary histories. Sea lions show curiosity toward humans too, particularly divers, sometimes approaching and circling them, investigating with gentle touches of whiskers or flippers. This inquisitiveness can be charming, but also potentially dangerous if the sea lion is territorial or protecting a pup. Wildlife experts recommend that humans maintain distance and never try to touch or feed wild sea lions. Advice meant to protect both species. These interspecies interactions reveal that sea lions perceive and engage with the broader community of ocean life, not existing in isolation, but as part of a complex web of relationships. The muscle composition of sea lions is adapted for sustained swimming and repeated diving rather than explosive sprints. Their muscles contain high concentrations of myoglobin, a protein that binds oxygen and turns the muscle tissue dark red. This stored oxygen can be used when the sea lion is underwater and cannot breathe, allowing the muscles to continue working. The muscles are also rich in mitochondria, the cellular structures that produce energy, giving them high endurance. Sea lions can swim for hours without tiring, maintaining moderate speeds that would exhaust most land mammals quickly. The flippers are powered by massive shoulder and chest muscles that ripple beneath the blubber layer. The core muscles are strong too, allowing the sea lion to twist its body sharply when pursuing agile prey. On land, different muscles engage, those in the back and belly that support the body's weight and propel it forward in that distinctive bouncing gait. Like any athlete, sea lions can improve their conditioning through activity. Young sea lions build strength and stamina through play and exploration, and adults maintain their fitness through the constant demands of hunting and swimming. An inactive sea lion would lose muscle mass and become less efficient. But this rarely happens in the wild, where survival demands continuous movement. The claws on a sea lion's flippers are small but functional, located at the tips of the digits that are hidden inside the flipper structure. On the front flippers, these claws are tiny nubs, barely visible beneath the skin and fur. On the rear flippers, the claws are slightly more prominent and are used for scratching, allowing the sea lion to relieve itches on its head and body. The sea lion will contort itself into various positions to bring the rear flipper up to scratch behind an ear or along its back, movements that look awkward but are clearly effective based on the satisfied expression that follows. These claws are remnants of a terrestrial past when sea lion ancestors walked on land with distinct toes and claws. As these animals adapted to marine life, the claws became less important. But evolution rarely eliminates structures completely. Instead, they are reduced and modified, repurposed for new functions, or simply maintained at minimal cost. The claws of a sea lion are evolutionary echoes, small reminders that these marine mammals still carry the blueprint of their land-dwelling heritage in their very bones. Sea lions can suffer from various diseases and parasites that affect their health and sometimes threaten entire populations. Leptospirosis, a bacterial disease, occasionally causes die-offs in sea lion colonies, particularly during El Niño years when warmer waters disrupt normal food webs and stress the animals. Domoic acid poisoning occurs when sea lions eat fish that have consumed toxic algae, leading to neurological symptoms including seizures and disorientation. Sea lions can also suffer from cancer, lungworm infections, and various bacterial and viral infections. External parasites, including lice and barnacles, may attach to their skin, and internal parasites, like worms, inhabit their digestive systems. Most healthy sea lions can tolerate moderate parasite loads without serious harm, their immune systems keeping infections in check. But stressed animals, those that are malnourished, injured, or very young, are more vulnerable. Marine mammal rescue centers treat sick and injured sea lions, administering antibiotics, fluids, and supportive care until the animals recover enough to be released back to the ocean. These rescue efforts have saved countless individuals and provided valuable insights into sea lion health and the threats they face. The gestation period of sea lions, from implantation to birth, lasts approximately 8 to 11 months depending on species. The developing pup grows within the mother's uterus, nourished through a placenta that transfers oxygen and nutrients from the mother's bloodstream while removing waste products. As birth approaches, the mother becomes more restless, often hauling out on beaches and rocks, selecting a spot where she will give birth. Labor is relatively quick compared to humans, usually lasting just a few hours. The pup is born tail first in most cases, and the mother may assist by gently pulling it free with her teeth, careful not to injure the newborn. The umbilical cord breaks naturally, and the mother may eat the placenta, recycling its nutrients. Within minutes, the pup is vocalizing and attempting to move, and the mother responds with her own calls, beginning the bonding process. The pup's first hours are critical. It must nurse successfully, establishing its ability to suckle and digest the rich milk, and it must avoid the surf and other dangers while still weak and uncoordinated. The mother stays close, guiding her newborn away from water and aggressive colony members, sheltering it until it grows strong enough to face the wider world. The thermoregulation challenges faced by sea lions vary dramatically with their environment and activity level. In cold water, heat loss is constant and significant, and the sea lion must generate heat through muscular activity and metabolism to maintain its core temperature. The blubber layer provides insulation but is not perfect. Heat still escapes, just more slowly than it would without blubber. The flippers, being thinner and lacking much blubber, are areas where heat can be lost quickly, so sea lions can control blood flow to the flippers, reducing it when conserving heat is necessary and increasing it when they need to dump excess heat. After vigorous swimming or on warm days, sea lions may overheat despite being in water. They will hold their flippers up to catch breezes, which cools the blood flowing through the flippers and carries that cooler blood back to the core. They may also lie partially in water with their flippers extended into cooler air. Or they may pant, releasing heat through evaporation from their mouths and respiratory passages. These behavioral and physiological strategies work together, allowing sea lions to maintain stable body temperatures across a wide range of conditions. The challenge is always present, the solution always adjusting, moment by moment, day by day. The bonds between sea lion mothers and their pups are strong and lasting, built through constant vocal communication and physical contact. The mother learns her pup's unique call within hours of birth, and this vocal signature remains stable throughout the pup's life. Even in a colony of thousands, a mother can pick out her pup's voice and will respond only to that specific call. This recognition is mutual. Pups learn their mother's voice equally well and will ignore other females who call to them. Researchers have tested this by playing recorded calls to mothers and the mothers respond strongly to their own pups' recording but ignore recordings of other pups. This vocal bond allows mothers to find their pups after being away hunting, and it allows pups to locate their mothers in the crowded, noisy colony. The system is not perfect. Occasionally, pups are separated from their mothers permanently through storms or accidents, or the mother's death. But most of the time it works with remarkable reliability. The bond typically lasts until weaning, but even after independence, young sea lions may maintain associations with their mothers, hauling out near them and interacting socially. These extended family connections create social networks that thread through the colony, invisible ties of kinship and familiarity. The speed and agility of sea lions underwater is impressive, achieved through powerful flipper strokes and streamlined body shape. When cruising, sea lions swim at speeds of about 5 miles per hour, a pace they can maintain for hours. When pursuing prey or fleeing predators, they can reach burst speeds exceeding 25 miles per hour. At these speeds, they become difficult targets for sharks and nearly impossible for human swimmers to match. Their acceleration is equally impressive, from stationary to full speed in just a few body lengths, propelled by explosive flipper strokes. They can turn sharply without losing much speed, their rear flippers acting as rudders while their flexible spine allows their body to bend and twist. They can swim backward by reversing their flipper motion, and they can spin in place, rotating their bodies without moving forward. This maneuverability allows them to hunt agile prey like squid and small fish that dart and dodge through three-dimensional space. Underwater, watching sea lions swim, they appear weightless and effortless, moving through water the way birds move through air, completely at home in their element. Sea lions are affected by changing ocean conditions, including warming temperatures and acidification, though the full impacts are still being understood. Warmer waters can shift the distribution of fish populations that sea lions depend on, forcing the sea lions to travel farther to find food or to switch to less nutritious prey species. El Niño events, which warm eastern Pacific waters, often correlate with poor breeding success and pup mortality in sea lion colonies, as the disruption to food webs leaves mothers unable to find enough food to sustain milk production. Ocean acidification, caused by absorption of excess carbon dioxide, affects the entire food web from plankton upward, potentially reducing the abundance of fish available for sea lions to eat. These environmental changes happen against a background of other human impacts, including fishing that competes for the same fish species. Sea lions eat pollution that introduces toxins into the food chain, and habitat degradation that removes beaches and rocks used for hauling out. Sea lions are adaptable animals with wide ranges and flexible behaviors, which gives them some resilience. But even adaptable species have limits. The populations we see today exist within a rapidly changing ocean, and their future depends on factors largely beyond their control. The seasonal movements of sea lion populations create predictable patterns along certain coastlines, with numbers swelling and ebbing through the year. In some areas, sea lions are present year-round, but in varying numbers as individuals come and go. In other locations, the entire population may migrate away for months, leaving beaches empty that were crowded weeks before. These movements follow food availability, breeding cycles, and perhaps simply the wandering tendencies of young animals exploring their range. California sea lions that breed on islands off Southern California may travel hundreds of miles north after breeding, showing up on docks and jetties in Oregon and Washington. They tend to be seen more frequently in these northern areas during fall and winter. Then numbers drop in spring as many return south for breeding season. Fishermen and coastal residents learn these patterns, knowing when to expect sea lions around piers and harbors. The regular appearance and disappearance of sea lions ties them to the rhythm of the seasons. Migrations less dramatic than those of whales or birds, but no less real. They are moving through their territory, using different parts of it at different times, an ancient pattern encoded in behavior and passed down through generations. The threats facing sea lions from human activities are numerous, though not insurmountable. Entanglement in fishing gear kills hundreds of sea lions annually, the animals drowning after becoming caught in nets or lines. Pollution introduces chemicals, including heavy metals and persistent organic pollutants that accumulate in sea lion tissues and can cause health problems, including reproductive failure and immune system suppression. Plastic debris in the ocean may be ingested accidentally, blocking digestive tracts or introducing toxins. Noise pollution from ships and industrial activity may interfere with sea lion communication and echolocation. Climate change brings multiple impacts, including shifting prey distributions and sea level rise that could affect haul-out sites. Despite these threats, many sea lion populations are stable or increasing, protected by legislation like the Marine Mammal Protection Act in U.S. waters. These laws prohibit hunting or harassing sea lions, allowing populations to recover from historical exploitation. Conservation efforts focus on reducing bycatch in fisheries, cleaning up pollution, establishing marine protected areas, and studying sea lion populations to detect problems early. The relationship between humans and sea lions continues to evolve, shifting slowly from exploitation toward coexistence. Sea lions occasionally strand themselves on beaches, sometimes in large numbers, events that can indicate environmental problems or disease outbreaks. Individual strandings may involve sick, injured, or malnourished animals that lack the strength to remain in the ocean. These animals beach themselves, perhaps seeking rest or warmth, though often they are too ill to survive without intervention. Marine mammal rescue organizations respond to reports of stranded sea lions, assessing each animal and determining whether it can be saved. Pups are sometimes found stranded after becoming separated from their mothers, and these orphans face poor survival odds without human help. Mass stranding events are rarer but more alarming, potentially signaling problems like harmful algal blooms, food shortages, or disease epidemics affecting many animals simultaneously. Scientists investigate these events carefully, looking for patterns and causes. Some stranded sea lions recover with treatment and can be released, returning to the ocean to resume their lives. Others are too far gone, and the kindest option is euthanasia. Each stranding tells a story, and collectively these stories inform our understanding of threats facing marine mammals. The vocalization patterns of sea lion colonies change throughout the day and night, creating a soundscape that rises and falls with activity levels. Dawn often brings increased calling as animals wake and begin moving, mothers and pups reconnecting after the night's separation. Midday may be quieter as sea lions rest in the sun, conserving energy between hunting trips. Late afternoon sees another surge of activity and sound as animals return from feeding or prepare to depart. Evening brings its own chorus as the colony settles for the night, though true silence never falls. Even in darkness, voices call out periodically, maintaining social contact. The acoustic environment of a sea lion colony is a living thing, breathing in and out, reflecting the collective rhythm of thousands of individuals. To stand at the edge of such a colony and listen is to hear something ancient and enduring, a conversation that has continued in these same places for thousands of years. Voices, layered upon voices across generations beyond counting. The ability of sea lions to recognize individuals extends beyond just mothers and pups. Adult sea lions can identify each other by sight, sound, and smell, remembering individuals they have encountered before. They form preferences and associations, choosing to haul out near certain individuals and avoid others. These social networks are complex, with some sea lions central and well-connected, while others remain more peripheral. Researchers studying marked individuals have documented friendships that persist across years. Females who repeatedly haul out together and whose pups play together as if by arrangement. Males remember rivals from previous breeding seasons and may resume their competition immediately upon encountering each other again. This social memory requires significant cognitive capacity, encode, holding mental representations of dozens or hundreds of individuals, updating those representations based on new interactions, using that stored knowledge to guide social behavior. The sea lion colony is not simply a crowd, but a community, structured by relationships and histories that individual sea lions carry in their minds. The curiosity of sea lions sometimes leads them into unusual situations, including exploration of rivers and harbors, far from typical marine habitats. Individual sea lions have been documented swimming dozens of miles up rivers, apparently following fish runs into fresh water. They may linger in these unusual locations for days or weeks before returning to the ocean. In urban areas, sea lions occasionally haul out on boats, docks, or even floating debris, treating human structures as just another type of rock. In San Francisco, sea lions famously took over docks at Pier 39 in the late 1980s, and their presence became such an attraction that the docks are now maintained specifically for them. These adaptable behaviors demonstrate that sea lions are not rigidly bound to traditional habitats, but can explore and exploit new opportunities when they arise. Their curiosity serves them well in a changing world, allowing them to discover new feeding areas and haul out sites as conditions shift. The maternal investment in sea lion pups is substantial and long-lasting compared to many marine mammals. A mother sea lion may nurse her pup for 6 months to a year, or even longer, during which time she must hunt frequently enough to sustain both her own body and her milk production. The energy cost is enormous. Nursing mothers lose significant body mass over the lactation period, their blubber reserves depleting as they transfer calories to their growing pups. Some mothers nurse multiple offspring simultaneously if the older pup has not yet weaned when the new pup is born, doubling their energy expenditure. This extended maternal care gives pups time to grow large enough and skilled enough to survive independently, but it limits how often females can reproduce. Most species produce only 1 pup per year, and if conditions are poor, females may skip years entirely, their bodies unable to support the demands of pregnancy and nursing. The bond between mother and pup, forged through months of intimate dependence, is built on this tremendous investment of time and energy, a biological commitment that shapes the arc of both their lives. Sea lions possess a sense of taste, though it appears less developed than their other senses and receives less scientific attention. They have taste buds on their tongues and in their mouths, and they can presumably distinguish between different flavors, though their preference seems to be for whatever fish species they have imprinted on or learned to hunt effectively. In captivity, sea lions show food preferences, choosing certain fish over others when given options, which suggests taste plays some role in their feeding behavior. They swallow most food whole or in large pieces, minimizing contact with taste buds, so taste may matter less to them than to animals who chew their food thoroughly. Smell likely contributes to their perception of food quality, the two senses working together as they do in most animals. The sense of taste, like so many aspects of sea lion biology, is adapted to their specific lifestyle, good enough to serve their needs without being extraordinarily refined, one tool among many in their sensory toolkit. The historical relationship between humans and sea lions has been complex and often destructive. Sea lions were hunted extensively for their blubber, which was rendered into oil, and for their hides, which were made into leather. In some areas, they were killed as competitors for fish, perceived as pests that reduced commercial catches. The Japanese sea lion was hunted to extinction by the mid-20th century, a cautionary tale of unsustainable exploitation. Other populations were dramatically reduced before legal protections were enacted. Today, most sea lions are protected by international law, though conflicts still arise when sea lions eat fish from nets or interfere with aquaculture operations. Some fishermen view them as competition, while others accept them as part of the marine ecosystem. The tourism value of sea lions is now recognized. People travel to see them, generating economic benefits that provide incentive for conservation. This shift from viewing sea lions as resources to exploit toward viewing them as wildlife to protect represents progress, though challenges remain in balancing human needs with sea lion conservation. The sleep requirements of sea lions are not precisely known, but like all mammals, They need regular rest to maintain health and cognitive function. The ability to sleep with half the brain at a time means sea lions can rest while remaining partially aware, perhaps reducing their total sleep time compared to mammals that must sleep completely. On land, sea lions may sleep for hours at a stretch, lying motionless, except for the rise and fall of breathing. In water, their sleep periods are likely shorter and lighter, constrained by the need to surface regularly to breathe. Pups sleep more than adults, as growing bodies need extra rest. After periods of intense activity or stress, sea lions may sleep longer or more deeply, recovering from exertion. The quality of sleep matters as much as quantity. Disruptions from noise, disturbance by humans or predators, or uncomfortable environmental conditions can all reduce sleep quality and potentially impact health. The sea lions sprawled on rocks, apparently oblivious to the world, are performing essential biological maintenance, their bodies repairing tissues, consolidating memories, and preparing for the next period of activity. The genetic diversity within sea lion populations is important for their long-term survival and adaptability. Populations with high genetic diversity have more variations in genes, which means more potential for adaptation if conditions change. Populations with low diversity are more vulnerable to disease, environmental changes, and inbreeding depression. Scientists study sea lion genetics by analyzing DNA from tissue samples, revealing patterns of relatedness and population structure. Some sea lion populations show evidence of genetic bottlenecks in the past, periods when population sizes dropped dramatically and rare genetic variants were lost. The California sea lion population appears relatively healthy genetically, while some smaller populations like the Australian sea lion show lower diversity and higher relatedness between individuals, a potential concern for their future. Conservation genetics helps inform management decisions, identifying populations that might benefit from measures to increase gene flow or protect remaining genetic variation. The genes carried by today's sea lions are the result of countless generations of selection and chance, and they will determine what variations future generations have to work with as they face an uncertain future. The phenomenon of sea lion rafting, where groups of sea lions float together at the surface, provides social interaction and rest while remaining in the water. A raft may consist of a few individuals or dozens, floating with flippers extended and bodies relaxed, sometimes with pups resting on their mothers' bellies. The animals may be resting between dives, digesting meals, or simply enjoying each other's company. Rafts often form in sheltered bays or kelp forests, where currents are gentle and the water is relatively calm. The kelp provides additional stability, its fronds wrapping loosely around flippers and bodies, anchoring the group in place. Rafting allows sea lions to remain in productive feeding areas without the energy expenditure of constant swimming, and it may provide safety in numbers, multiple animals watching for predators. The sight of a sea lion raft, animals floating peacefully in dappled sunlight with water lapping gently around them, evokes a sense of complete contentment, as if they have found a perfect moment and are savoring it fully. The whisker arrangement on a sea lion's face follows a specific pattern, with moustachial whiskers on the upper lip being the most prominent and numerous. Additional whiskers grow above the eyes and on the chin, creating a sensory array that surrounds the mouth and extends the sea lion's awareness in multiple directions. The whiskers are not all the same length. Those near the front of the face are typically longer, extending several inches from the skin. Each whisker can move independently, controlled by small muscles at its base, allowing the sea lion to orient its whiskers towards stimuli of interest. The whiskers are replaced periodically, falling out and being replaced by new growth, though not all at once. At any given time, most whiskers are present and functional. The density of nerve endings at the base of each whisker means that even slight deflections produce strong signals, making the whisker system extraordinarily sensitive. This sensitivity extends to detecting water movements, but also to physical contact. Sea lions use their whiskers to explore objects by touch. running them over surfaces to gather information about texture and shape. The calcium and phosphorus content of a sea lion's diet, obtained from eating whole fish, including bones, supports their own skeletal needs. Unlike humans who require dairy or supplements to meet calcium requirements, sea lions get everything they need from their natural diet. The bones they consume are digested partially, the minerals extracted and incorporated into their own growing or maintaining skeletons. This dietary calcium is especially important for pregnant and nursing females, whose calcium demands increase dramatically. The developing pup in utero needs calcium for its skeleton, and nursing pups extract calcium from their mother's milk to build their bones. If dietary calcium is insufficient, the mother's body will leach calcium from her own bones to supply the pup, potentially weakening her skeleton. This is one reason why adequate nutrition is so critical for breeding females. They must maintain their own health while supporting their offspring's growth. The cycle of calcium from ocean to fish to sea lion to pup represents one thread in the complex web of nutrient cycling that connects all marine life. The age at which sea lions reach sexual maturity varies by species and sex, with females typically maturing earlier than males. California sea lion females may become sexually mature at 4 to 6 years old, though they may not successfully rear a pup until a year or two later. Males reach sexual maturity around the same age, but usually cannot compete successfully for territories until they are 9 or 10 years old and have reached full adult size. This means males have a delayed reproductive maturity, capable of breeding but unable to access breeding opportunities until they grow large and strong enough to compete with established bulls. Stellar sea lions follow a similar pattern, but with slightly later maturation ages. This difference in reproductive timing between males and females means that more females than males contribute to each generation, which affects genetic diversity and population structure. Young males who cannot compete for territories may still occasionally sneak matings with females on the periphery of established territories, but most reproduction is controlled by dominant bulls who have proven their fitness through competition. The effect of El Niño events on sea lion populations provides clear evidence of how environmental variability affects marine mammals. During El Niño years, warm water spreads across the eastern Pacific, disrupting the normal upwelling patterns that bring nutrients to the surface. This collapse in productivity ripples up the food chain. Less phytoplankton means less zooplankton, fewer small fish, and hungry sea lions. Pup mortality increases during these years as mothers cannot find enough food to produce adequate milk. Adults may lose significant body mass, and some die of starvation. The effects can last for months or even years as populations recover after the El Niño ends. The 1997-98 El Niño was particularly severe, causing massive die-offs of sea lions along the California coast. These events are natural occurrences that sea lion populations have survived for thousands of years, but they become more concerning when combined with other human-caused stresses. A population already stressed by pollution, habitat loss, or overfishing may be pushed beyond its resilience by an El Niño event that it would otherwise survive. The interactions between natural variability and human impacts are complex and not fully understood, making prediction difficult and management challenging. The territorial displays of male sea lions during breeding season are elaborate performances designed to intimidate rivals without necessarily fighting. A bull establishes his territory and then advertises his presence through vocalizations, postural displays, and boundary patrols. He may stand tall on his front flippers, raising his head and chest high to maximize his apparent size. He vocalizes loudly, a deep roar that echoes across the colony. He moves along the edges of his territory, marking it with scent and chasing away intruders. When a rival approaches, the resident bull intercepts him at the boundary, and both males engage in a ritualized confrontation. They face each other, sometimes chest to chest, pushing and trying to overpower without immediately resorting to biting. They may lunge and feint, testing each other's commitment. Most of these confrontations end with one male backing down, the weaker or less committed individual retreating without serious injury. Actual fights, when they occur, involve biting at the neck and shoulders. Attempts to grab the opponent and throw them off balance. The thick skin and blubber of adult males protects them from most bites. Though scarring is common, these territorial battles look violent but rarely result in life-threatening injuries. The system has evolved to determine dominance while minimizing risk to both participants. The ability of sea lions to fast for extended periods during breeding season, particularly males who may go 2 months without eating while defending territories, requires significant physiological adaptations. During fasting, the body shifts metabolism to preserve muscle, while burning fat stores for energy. Protein breakdown is minimized, protecting vital tissues. The metabolic rate may decrease slightly, conserving energy. Water can still be obtained from metabolic water, produced when fat is broken down, though males also have access to seawater, if needed. Despite not eating, the male must remain active and vigilant, defending his territory against challengers and interacting with females. By the end of breeding season, territorial males have lost 25 to 30% of their body weight, their blubber layer greatly reduced, and their muscles somewhat wasted. They leave the breeding grounds exhausted and must spend weeks feeding intensively to rebuild their reserves. This extreme fasting is possible only because of the large fat stores built up before breeding season begins. It represents an enormous investment in reproduction, sacrificing immediate survival and health for the chance to pass genes to the next generation. The learning capacity of sea lions extends to complex cognitive tasks, including understanding abstract concepts. In laboratory studies, sea lions have learned to match shapes, colors, and sizes, demonstrating that they can grasp concepts of similarity and difference. They can learn if-then rules, applying them to new situations they have not encountered before. They can use logic to solve problems, eliminating incorrect options to arrive at correct answers through deduction. One famous sea lion named Rio learned to understand equivalence relationships, recognizing that if A equals B and B equals C, then A must equal C, a transitive inference that requires sophisticated reasoning. These abilities suggest that sea lion intelligence extends beyond simple associative learning into realms of abstract thought and reasoning. In the wild, this intelligence manifests in flexible hunting strategies, complex social navigation, and the ability to learn from experience and adjust behavior accordingly. Sea lions are not operating purely on instinct, but are thinking animals capable of solving novel problems and adapting to changing circumstances. The buoyancy challenges faced by sea lions change as they dive deeper. Near the surface, their blubber and the air in their lungs make them positively buoyant, floating naturally upward. They must swim down actively, working against their tendency to rise. As they descend, increasing pressure compresses the air in their lungs, reducing their volume and their buoyancy. At some depth, they reach neutral buoyancy, where they neither sink nor float, maintaining depth without effort. Deeper still, they become negatively buoyant, sinking naturally and having to swim upward to maintain their depth or return to the surface. This changing buoyancy means that diving and ascending require different strategies and different amounts of effort depending on depth. Sea lions adjust automatically, their experienced bodies knowing how much effort is needed at each stage of a dive. The physics of buoyancy and compression are constants that every diving animal must navigate, invisible forces that shape the experience of moving through water's vertical dimension. The lifespan variation between male and female sea lions, with females typically outliving males by several years, reflects the different challenges each sex faces. Males endure the stress of competing for territories and fasting during breeding season, which takes a physiological toll. They suffer more injuries during territorial disputes and may be more vulnerable to predation when weakened by fasting. Females avoid these stresses, but face the energy demands of pregnancy and nursing repeatedly throughout their lives. Despite this, females generally cope better with these costs than males cope with breeding competition. The result is that in most sea lion populations, adult sex ratios skew toward females, not because more females are born, but because males die younger. This pattern is common in polygynous species where males compete intensely for mating opportunities. The oldest individuals in any sea lion colony are almost always females, matriarchs who have seen decades of seasons and raised multiple generations of pups. They carry knowledge and experience that benefits the entire colony, and their presence provides stability and continuity. The response of sea lions to human presence varies tremendously based on their history with humans and the behavior of the people they encounter. Sea lions in protected areas, where feeding and harassment are prohibited, tend to be cautious but tolerant of quiet observers who keep their distance. In areas where people have fed them, or where they associate humans with fishing activities and easy food, they may be bold and approach humans closely, sometimes becoming aggressive in attempts to obtain food. Sea lions that have been rescued and rehabilitated may be less fearful of humans than truly wild animals, though rehabilitation protocols try to minimize human contact to preserve wild behavior. Young sea lions, particularly pups, are naturally curious and may approach divers or swimmers out of simple inquisitiveness, not recognizing potential danger. Wildlife managers work to maintain appropriate distance between humans and sea lions, preventing habituation that could lead to conflicts. The ideal relationship is one of mutual respect, humans appreciating sea lions from a distance that does not disturb natural behaviors, and sea lions maintaining their wild wariness that protects them from harm. The role of sea lions in marine ecosystems extends beyond their direct impact as predators. They are prey for sharks and orcas, transferring energy up the food chain to these apex predators. When they die, their bodies may sink to the ocean floor, providing food for scavengers and nutrients for deep-sea ecosystems. Their feces release nutrients into the water, supporting plankton growth and contributing to local productivity. At haul-out sites, their presence affects terrestrial ecosystems too. Their feces fertilizes plants, their bodies compress and alter vegetation, and their remains feed coastal scavengers. They are nodes in a complex web of relationships, affecting many other species, and being affected by them in turn. The health of sea lion populations can indicate the health of broader marine ecosystems, as these animals integrate information about food availability, pollution, climate patterns, and other factors through their survival and reproduction. Scientists monitor sea lion populations not just for their own sake but as indicators of ocean health, watching for signals of larger environmental changes. The sounds produced by sea lions underwater differ from their above-water vocalizations, adapted to the different medium. Underwater calls tend to be clicks and chirps, higher frequency sounds that travel well through water. These may serve for echolocation, allowing sea lions to detect objects and prey using sound reflections, though this ability is not as developed as in dolphins or toothed whales. Sea lions also produce sounds underwater that may function in communication, though less is known about this compared to their well-studied above-water vocalizations. The acoustic environment underwater is very different from air. Sounds travel faster and farther, and the sea is filled with natural sounds from waves, marine life, and geological processes. Sea lions navigate this soundscape using ears, adapted to hear well in both media, switching between two acoustic worlds as they move between land and water. This dual acoustic existence is another example of their adaptation to life at the boundary between realms, equally at home in the voices of air and water. The courtship behavior of sea lions is relatively simple compared to many species, focused primarily on male territorial defense and female choice. Males do not perform elaborate courtship displays directly to females, but instead advertise their quality through territory holding and physical condition. Females assess males based on territory quality and perhaps on the male's ability to defend that territory against rivals, which indicates strength and fitness. Mating itself is brief, occurring on land or in shallow water, and females may mate with multiple males if they move between territories. There is no pair bonding. Males and females do not form lasting relationships, but come together only for the brief time necessary to mate. After mating, the female bears all responsibility for the developing pup, while the male continues defending his territory and mating with other females if possible. This mating system, called polygyny, is common in pinnipeds and results from the ecology of these animals. Females concentrate in predictable locations for pupping, allowing males to defend access to multiple females. The system works, producing new generations year after year, though it creates intense pressure on males and places full parenting responsibility on females. The pelvic bones of sea lions are reduced compared to typical terrestrial mammals, but still present, serving as attachment points for muscles that control the rear flippers. These bones are not connected to the spine as they are in most land mammals, instead floating free within the body wall, held in place by muscles and connective tissue. This arrangement provides flexibility, allowing the rear flippers to move through a wide range of motion, useful for swimming and for walking on land. The evolution of pinnipeds from terrestrial ancestors involved substantial modification of the pelvis and hind limbs, transforming walking legs into swimming flippers while retaining enough structure to allow movement on land. Sea lions represent an intermediate state, more mobile on land than true seals who have fully committed to aquatic life, but less terrestrial than their distant ancestors. The skeleton records this evolutionary compromise. Bones modified but not eliminated, adapted to serve new functions while retaining echoes of their original purposes. The impact of noise pollution on sea lions is an area of growing research concern. Underwater noise, from ship traffic, sonar, seismic surveys, and construction can reach levels that may interfere with sea lion hearing and communication. Temporary threshold shifts, where hearing is temporarily impaired after exposure to loud sounds, have been documented in captive sea lions exposed to various noise sources. Chronic exposure to moderate noise might mask important sounds, making it harder for sea lions to detect prey, predators, or each other's calls. On land, noise from aircraft, vehicles, and human activities at haul-out sites may disturb resting animals, causing them to flee into the water and expending energy unnecessarily. The long-term effects of noise pollution on sea lion populations are difficult to determine, but there is concern that cumulative impacts could affect health, stress levels, and reproductive success. As human use of oceans intensifies, managing noise pollution is becoming increasingly important for marine mammal conservation. The whisker tracking ability of sea lions has inspired technological applications, with engineers studying how these animals detect and follow hydrodynamic trails to develop underwater robots with similar capabilities. The mechanism is remarkable. As an object moves through water, it sheds vortices that persist for tens of seconds, and the specific pattern of these vortices contains information about the object's size, shape, and trajectory. Sea lion whiskers detect these vortices through subtle pressure changes and movements, and the sea lion's brain processes this information to reconstruct the path the object took. Robots, equipped with artificial whiskers based on sea lion whiskers, could track submarines or search for objects in murky water where cameras are useless. This is an example of biomimicry, where human technology learns from natural solutions refined by millions of years of evolution. The sea lion's whiskers solve a problem that engineers are only beginning to understand, and studying them provides insights that may lead to practical applications in underwater navigation and sensing. The range of depths at which different sea lion species hunt reflects their prey preferences and physiological capabilities. California sea lions typically hunt in relatively shallow water, from the surface down to about 300 feet, where they catch schooling fish like sardines and anchovies. Steller sea lions hunt deeper, regularly diving to 600 feet and capable of reaching 1,500 feet or more, pursuing bottom-dwelling fish and squid. These deeper dives require greater pressure tolerance and longer breath hold times, pushing the limits of sea lion physiology. The deepest diving sea lions show adaptations, including larger body size, which provides more oxygen storage capacity, and perhaps enhanced myoglobin content in muscles. The choice of hunting depth is not arbitrary but reflects an ecological niche. Different species exploit different parts of the water column, reducing competition between them. This depth partitioning allows multiple sea lion species to coexist in the same geographic area by feeding on different prey at different depths. The satellite tagging of sea lions has revolutionized understanding of their movements and behavior at sea. Tags attached to sea lions transmit signals to satellites overhead, allowing researchers to track individual animals for months as they travel across vast distances. These tracks reveal hunting strategies, migration routes, and how sea lions respond to changing ocean conditions. Combined with dive recorders that log depth and duration of each dive, the tags provide detailed activity budgets showing how sea lions spend their time. The data reveal individual variation. Some sea lions are consistent in their patterns, while others are exploratory. Some dive deep, while others stay shallow. Some travel far, while others remain near their colonies. This variation within populations is important for adaptation, providing options for responding to environmental changes. The tags eventually fall off as the sea lion molts, sinking to the ocean floor with their data transmitted, leaving the animal unmarked and free. The insights gained from these brief attachments inform conservation decisions and deepen understanding of sea lion biology. The relationship between sea lion mothers and their female offspring sometimes extends beyond weaning, with daughters returning to their mother's territories to give birth to their own pups. This creates multi-generational family groups, where grandmothers, mothers, and daughters may haul out together, their pups playing together. These family associations may provide benefits, including shared knowledge of good feeding areas and mutual vigilance against predators. Male offspring typically disperse farther after weaning, eventually leaving their natal colonies entirely, though some return to breed if they successfully compete for territories. This sex-biased dispersal, with females philopatric and males dispersing, prevents inbreeding while maintaining female family groups. The social structure of sea lion colonies is thus built on networks of related females who may recognize and favor their relatives, creating communities held together by bonds of kinship. And now the sea lions fade behind your thoughts, their barks growing distant, their forms dissolving into the gentle rhythm of waves. We've drifted through 100 quiet truths about these graceful mariners who live between worlds. From their external ears that catch the sounds of both air and ocean, to their whiskers that read the water's invisible stories, from their powerful flippers that make them seem weightless in the blue depths, to the bonds between mothers and pups that transcend the chaos of crowded colonies. You are connected to this world, sharing with sea lions the heritage of warm blood and breath, the mammalian lineage that branched millions of years ago but never fully severed. Their ancestors walked on land as yours did, and some part of them remembers, carrying that memory in bones adapted but not transformed, in lungs that still breathe air, in mothers who nurse their young with milk rich enough to fuel growth in the cold embrace of the sea. Tonight, as you rest, sea lions continue their ancient patterns along rocky shores and in the depths beyond sight. Mothers are returning from hunting trips to find their pups waiting, calling out across the darkness. Bulls are defending their territories, their roars echoing over moonlit waves. Pups are learning to swim in protected coves, gaining confidence with each small adventure. And somewhere, a sea lion is diving deep into the twilight zone, following trails only whiskers can detect. Hunting in darkness, with senses refined across countless generations. You are safe, warm, resting in a world full of wonder. A world where sea lions dance through currents and haul out on sun-warmed rocks, where mothers find their pups among thousands by recognizing a single voice, where intelligence and instinct blend seamlessly into lives lived between land and sea. If you're still awake, go ahead and watch the next chapter. Sleep well and dream softly, perhaps of the ocean's rhythm, of sunlight filtering down through blue water, of the peace that comes from simply floating, cradled by the sea. Good night.